Okay, on to question 1. If x% more than 160 equals x% less than 180, and if n is a positive integer such that nx is an integer, okay, I need to find x. And then what is the smallest possible value of n over here? Okay, x% more than 160 is nothing but, let's write it down as 160 into 1 plus x by 100, right? It's just an equation we're getting with one variable. 180 into 1 minus x by 100, right? X% less than 180. I mean, this is how it is. I'm not going to get into the basics as to why and what. You can simplify over here. You can write this as 9 and you can write this over here as 8. That's it. 8 plus 8x by 100 equals 9 minus 9x by 100. Take the 8 there and you get 1, and you bring the 9x over here and you're getting 17x by 100. X equals 100 by 17, right? So x equals 100 by 17. Now what is the smallest value of n such that nx over here is going to be an integer, and n is a positive integer. Smallest value I have to multiply this with to get an integer is going to be 17, so that the denominator gets cancelled over here. So therefore 17 is the answer, right? 17 is going to be the value of n, so that nx becomes an integer. On to the second question over here. The pass mark in a test is 40%. If a candidate's score in the test is 60% more than the pass mark, okay, and 27 marks less than the total marks, then the mark required to pass the test is what, right? These are the questions we have to pick in the exam. But how do we do it? Pass over here, we can just write it as 40%. Now, candidate score, right? The score of a candidate in the test is 60% more than the pass mark. This is given in percentage terms. What is 60% of 40%, right? I mean, you should be knowing at this stage, or do 60 into 100 by 100 into 40. 2 zeros knock off and you get a 24, right? Or you should know that 6 fours are 24, it comes to that. But this is going to be 60% more than this, right? 24% more than 40% is coming to 64%, okay? And that is 27 marks less than the total marks, right? Total marks in terms of percentage is going to be 100%, right? I know the difference over here in percentage terms is 36%. In actual marks terms is given to me as 27, right? Then the marks required to pass the test, then 40% is going to be what? Now, several ways to do it. You can, this is the missing value which we need to find. What I've taught is product of the known diagonal divided by the opposite value is always a foolproof way of finding that, right? And you can just divide over here, you get 3/4. 3/4 of 40 is going to be 30, and therefore 30 marks is required to pass the test. That's one way of doing it. Or you can say that this is, over here is 3/4 of this. So find 3/4 of this, right? Find in terms of portion of this is what? 3/4 of 40 is 30, right? 2-3 ways of doing it, but eventually you get an answer of 30, right? Again, these questions, avoid using a variable so that you get speed, okay? On to the third question. Meena scores 40% in an examination, and after review, even though her score is increased by 50%, means 40% has now become 60%, right? It's 50% of 40 has gone up by, right? So you can write 40%, that is Meena. Now after review, it's come up to 60%, right? Half more. 50% is nothing but half more. She is failing by 35 marks, right? She's failing by 35 marks, okay? So let's say pass over here. We don't know what it is, but this is going to be 35 marks less, right? I'm using a top down, indicating that higher you go, I mean, higher the marks you write at the top, lower in the bottom, right? I know the difference between pass and after review score of Meena is 35, right? Still failing by 35. If a post review score, right? And post review score, what is happening over here? It increased by 20%. 20% or 1/5 of 60. 20% over here is 1/5. You should know that. 1/5 of 60 is 12. 12 more over here is 72%. Again, I'm skipping a lot of steps. I'm not writing them down. Need to be observant, right? 1/5 of this more is 72%. And what is happening over there? She would have had 7 marks more than the passing score. So after review, there is another post review happening over here. In post review, if you get 20% more, 1/5 more, you're getting to 72%, and you're still short by 7 marks, right? This pass mark over here, was 7 marks less than 72%, 35 marks more than 60%. The question asked is the percentage score needed for passing the exam is what, right? What is the score required to pass the exam? All we need to find is in terms of percentage. I just need to find this percentage over here. So 7 is to 35. I have to split, right? 7 is to 35 is nothing but 1 is to 5. In that ratio, I have to split. What is the total over here? 72 plus minus 60. That's a total of 12%. How do I split 12 in the ratio of 1 is to 5? That's going to be 2 is to 10, right? So 2 is to 10 over here. 72 minus 2% or 60 plus 10%. In both cases, I get 70%, right? So 70 becomes the answer over here. On to question 4. Ram has 40% more money than that with Raja, but 30% less than that with Mohan. Mohan has 20% more money than that with Roy. Okay. Raja, Ram, Mohan, Roy. I think we'd be knowing. Right. That was actually one person broken down into 3 or 4 people over here. And what do we know? The amount of money is going to be different, and there's some linkages given over here. We can use ratios, right? We can use ratios. How do we do that? 40% over here is nothing but 2/5. 30% is 3 by 10. 20% is 1/5, right? So remember that. Then while trying to link them with ratios is going to become easy, right? Let's see how. Ram has 40%, 2/5 more than that with Raja. Ram has 2/5 more than Raja. Raja has 5 parts, right? Whatever is the denominator put over there, 2/5 more is going to be 7, right? That's with Ram. But, so that continues. Ram, however, has 30% less than that with Mohan, right? If Mohan had 10 rupees, Ram has only 3/10 less. Mohan had 10 rupees. Ram had 3/10 of this less, which is 3 parts less, comes to 7 rupees. Perfectly fits. 5 is to 7 is, and here you have 7 is to 10 for Ram is to Mohan. We can write it in one line itself, right? It anyway, it's like the same. This is about linking ratios. If the parts are the same, you can just merge them and write as one. Mohan has 1/5 more money than with Roy. Okay. Mohan over here has 1/5 more than with Roy. So if Roy was 5, Mohan over here is going to be 1/5 more, which is 6. So 6 is to 5. I need to merge these two ratios over here. Common linkage over here is that with Mohan. The LCM over here for 6 and 10 is going to be 30, right? 30. For me to get that, I have to multiply this with 3 and multiply this ratio over here, 6 into 5 over here. So I'm getting 5 5s are 25, right? The other one, 3 7s are 21 and 3 5s are 15. Once that is done, what else is given here? The total sum of money with the 4 of them, all 4 put together, is less than 2,000. And the amount of money with each of them is an integer. Okay. Then the maximum possible amount of money with Mohan alone. Okay. So what's the total over here? Total in terms of parts, 25 plus 15 is 40, plus 30 is 70, 70 plus 21 is 91. Now, the amount of money with each of them is going to be a multiple of these. And all of them have to have integer amounts in rupees. Now, the condition over here is 91 into something should be less than 2000, right? So 91 into 20, 2 9s are 18, no? So this comes to 1820, right? 182 and a 0. That's less than 2000. Add one more 91 and the 91 under the 20 and we get a 1911. We add another 91, it's going to go past 2000, right? So therefore 1911 is where we stop. And 1911 is nothing but 91 into 20 plus another 91. So this is a 91 into 21, right? Into 21 comes to 1911. Now what is asked is in terms of Mohan. So into 21 and that amount comes to 630. So 630 over here becomes the answer. Moving to the fifth one, right? So on to the fifth question. 3 machines A, B and C produce 20%, 35% and 45% of the total output of a company. Okay, 3 out of 200 units produced by machine A are defective, while 6 out of every 105 are okay, and 20% over here are defective. What percentage of the total output of the company are defective? Okay, everything is given in percentage or relative terms. Let's assume a total output. Let the total output be, wait, the final percentages are 1 decimal place. So let's take the total output to be total output. Okay, so let's do it this way. Let's write it as A, B, C, and total, right? Output over here, let's take it to be 1000. So I know 20% or 200 parts are produced by three machines, A, B, and C. So 200 are produced by A, 350, 35% of 1000, and 450 over here. Okay, what do we know? 3 out of 200 produced by A are defective. Perfect. So I have the defective over here, 3. Because 200 is the output, means 3 are defective. Next, 6 out of every 105. And I have 350 here. So 6 by 105 into 350. You got to further simplify this and say if 6 out of 105 divided by 3, you get 2 for every 35 units, right? And that's it. So this you multiply and you get a total of 2 into 10, 20 units. So 20 units are defective, 350 are produced by B. And lastly, 20% of the output for C. And 20% we should know is 1 by 5. 1/5 of 450 is 90. We add these up, we get 1, 1, and 3. 1, 1, 3. 113 defective for every 1000. That means that's 11.3%, right? 113 by 1000 into 100%. Shouldn't be wasting time with all of these. Should know is going to be 11.3%. On to the question 6, right? So Raju has a car factory last month intending to triple the production. Okay, wanted to triple the production. He adds high-tech machines which are 150% more productive than the existing machines. What is the ratio of the number of existing machines to new machines if the actual production is 20% lower than that anticipated? Okay, so what's happening over here? We have adding, right? Not replacing. He's adding high-tech machines, okay, which are 150% more productive than existing machines. What's the ratio of the number of existing to new machines? Okay, so what you need to do over here is you can assume values, relative terms, ratios, 150%, 20%, no absolute value. You can assume values over here, right? Two things to be assumed over here. Existing machines, right? Existing machines, let's say there are 100, right? Number of machines is 100. It's also going to have a certain output, right? Output over here. Let's take the output of each machine. Output per machine, let's take that to be 100 as well, right? I know it's a big number. You can take something smaller, but it's okay. So we can take it as 10,000, right? That's going to be the total output. Actual output, number of machines into output per machine is the output. Now, what did Raju want to do? Wanted to triple the production. That is, bring it to 30,000, right? Wanted to bring it to 30,000, but did not achieve that. Ended up being 20% lower, 1/5 lower. 1/5 of 30,000 is 6,000. Ended up becoming only 24,000, right? Ended up being only 24,000. Now, 10,000 anyway came from the existing machines. 14,000 was the output of the new machines. So the new machines were able to produce 14,000, but at what productivity? What was the output per machine? 150% more productive. 150% of 100 is 150, but 150% more extra. So add 150 and you get your 250. Now, what into 250 is 14,000, right? That's the question. 1000 by 250 is 4. 14 into 4 is 56, right? If you want, you can write it down separately and try to do it. All I'm trying to say is 1000 by 250, right? That's going to be 4. 1000 by 250. 4 into 14 will come to 56. The question asks this: what is the ratio of the existing to new? 100 is to 56. 100 is to 56. Divide by 4. You get your 25 is to 14. Option 1 becomes the answer here. 3 more questions. 4 more questions, then we'll pause. Yeah. On to question 7. In a class, 60% of the students are girls and the rest are boys. If there are 30 more girls than boys, we are given absolute value over here. Okay. If 68% of the students, including 30 boys, pass an examination. So straight away, you should know there are 2 attributes: girls and boys, pass and fail. Okay. So let's take girls over here and then boys, and then the total over here. Always form a table in these scenarios: a pass and a fail, and you have another total. Now, what is the total number of students over here? We don't know. at some absolute value is given to link it up. Okay, let's look at this. 60% are girls, 40% are boys. There are 30 more girls than boys. 60% minus 40%, 20% of total, right? How many more girls are there than boys? 60 minus 40, 20% of total. That's nothing but 30, because we have 30 more girls than boys. So 20% is nothing but 1/5, right? 20% is nothing but 1/5. You take that 1/5, I mean the 5, and throw it there, and you get a 150. So 150 is the total. 40%. For 2/5 of this, that's going to be 60 over here. Girls is going to be 30 more, 90. Everything works out properly, right? The 60%. Okay. Now that we're done with that, if 68% of the students, including 30 boys, pass an exam, so 30 boys are passing, right? Passes 30 for the boys, 68% of this for the total. So 68 by 100 into 150. Okay. 3 and 2. 2 you divide over here, and that's a 34. 34 threes are 102. So total is 102. 102 minus 30, that's going to give us 72. And over here, the difference is 18, and the difference over here is 30. Here, if you want, you can write it down. That's the total of these two, 48. But what's asked? The percentage of the girls who do not pass. Percentage of the girls. Immediately after the word, word of, whatever comes is my denominator. Percentage of the girls. Total girls, 90. Of them, how many do not pass? 18 do not pass, right? 18 of them fail. 18 by 90 as a percentage. 18 by 90 is nothing but 1/5. 1/5 as a percentage, you should know, is 20%. Multiply with 100% to the base, and you would get your 20. That's the answer here. On to question 8. In an election, there were 4 candidates, and 80% of the registered voters casted their votes. One of the candidates received 30% of the casted votes, while the other 3 candidates received the remaining casted votes in the proportion 1:2:3. Right? So this is a CAT question, one of the tougher ones which turned up that year. If you have the right structure, it's going to be easy, right? Now, what's asked over here, if the winner of the election received 2512 votes more than the candidate with the second highest votes, then the number of registered voters was how much, right? And some big numbers over here. Generally, students tend to avoid this, but you should look to approach these, because everything is given in terms of percentages and ratios, and just one absolute value persists with this, right? You have a total of 4 candidates. 80% of them cast the votes. Okay, 80% have casted their votes, right? 80% of the registered voters. I need to find the number of registered voters. Okay, of this 80%, what has happened? One of the candidates has received 30% of this, right? Of the casted votes, and 30% of 80% is 24%. Okay, now what about the rest? The rest over here is going to be 56%, right? Difference between these two. And this was divided in the ratio 1:2:3, right? 1:2:3. We can write it as 3:2:1, whichever way you want it, right? The reason I'd go for that is 3/6 is half of this 28%. Okay. Next is 2/6 or 1/3 of this, right? And 1/3 of this 18, 2 by 3%. And the last 1/6 of this, right? 56 by 6. That's 28 by 3, and that comes to 9, 1 by 3%, right? Quick check. Need be, yeah, it all adds up to 56. Now, what's given here is the winner of the election received 2512 votes more than the candidate with the second highest. Who's the winner here with these percentages? 28% is the winner. Who's number 2? Number 2 is 24%. Now, the difference between these two, 4%, is what? Is 2,512 votes, right? That's the difference between the winner and the second. So 4% is 2,512. I need to find the number of registered voters. Registered was 100%, right? The total, the grand total. From 4%, how do I get to 100%? By multiplying with 25. I need to do the same over here. 2,512 into 25 is the total, right? Is the total. So one suggestion when you have to multiply these, if you have a calculator, use it, right? Or you could do an into 4 divide by 4, right? The value doesn't change. But I know this 25 into 4 is going to give me 100. So 2 zeros. 2,512 by 4. 6 fours are 24. And then you have 11. 2 fours are 8. And then a 32. 8 fours are 32. And you get option 2, 62,800. On to question 9. In the final examination, Vishnu scored 52% and Asha scored 64%. The marks obtained by Vishnu is 23 less, and that by Asha is 34 more than the marks obtained by Ramesh. So there's an in-between Ramesh coming into picture. Okay, so let's write down. As I said earlier, Vishnu over here is 52%, Asha over here is 64%, and in between Ramesh is coming. And Ramesh over here is what? Marks obtained by Vishnu is 23 less than Ramesh. Vishnu is, this part is 23, okay? And Asha is 34 more than Ramesh. So Asha over here is 34 more than Ramesh. So what is the difference between A and B directly? 34 plus 23, which comes to 57. What is the difference between them in terms of percentage? Direct subtraction, 12%, right? The gap over here is 23, the gap over here is 34. The direct gap between A and B is going to be 57, the sum of these two. So 57 is 12%, what's asked here? The marks obtained by Geeta, who scored 84%, is somehow how much? Somebody scored 84%. 12 into what is 84%? Into 7. Do the same here, into 7, right? 5 sevens are 35. 350 plus 49, that's 399. Mark it, keep going. This is one of the quickest ways of solving this without using variables, right? So just write it in terms of top to bottom, right? In terms of marks, it's easy to visualize and figure out these. I mean, too easy to place these values and solve them quickly. On to question 10. In a tournament, a team has played 40 matches so far and won 30% of them, okay? If they win 60% of the remaining matches, their overall win percentage will be 50%. They won as much as they've lost, okay? Suppose they win 90% of the remaining matches, the total number of matches won by the team in the tournament will be how much? There are 2-3 ways of doing it. I've solved this question in the past. This is a CAT question. I'll use a different approach right now. I mean, generally we tend to use, we like to use variables, so let's go for that. The team has played 40 matches and won 30% of them. So wins over here and losses, let's say, right? 30% of 40, 12 wins, 40 minus 12, the remaining 28 are losses. If they win 60% of the remaining matches, 60% is 0.6, right? As in the decimal form, let the remaining matches be X. If you win 60% of the remaining matches X, then you have, if 60% are wins, the remaining 40% are losses. The losses are 40% of the remaining matches, 0.4x. We are told that the overall win percentage will be 50%. So half our wins means the remaining 50% are losses. So these two should be equal. One equation, one variable, we should be able to solve for it. Bring the 0.4x here, 0.2x, take the 12 there, you get a 16. X equals, this is 1/5, right? So there's nothing but 1 by 5. Take the 5 and throw it there, and you get an 80. Right? Initially, you had 40 matches, then you have 80 more matches, additional matches. Now, what is the question over here? Suppose they win 90% of the remaining matches, then the total number of matches won by the team, total, right? So initial wins was given to us as 12, right? 30% of 40, which is 12. Then additional wins now from the additional 80 matches, if 90% are going to be victories. What is 90% of 80? Get rid of the 2 zeros. The percentage symbol takes care of it. 9 8s are 72. Add these two, you get 84 as the total number of wins over here.